Hey, what's up, gang? Dr. Stouts here. We are wrapping this thing up. We just got a couple weeks left, and then it will be hello summer. So hope everybody is doing well. Um, we last week we talked about monatomic ions, and hope you guys did well on those. From everything that I looked at and graded, everybody seemed to grasp that pretty good. So we introduced ionic bonding and cations and anions and positive and negative and all that jazz. So today we're just going to build on top of that, and we're going to move on to something called binary ionic compounds. Sounds pretty scary, but it's not. So let's just jump into it. You may have heard the term binary before. Anytime you see the word binary, it just literally means two. There's two of something. With binary ionic compounds, we are going to build off of those monatomic ions that we talked about last week. So some examples there, you've got sodium, it's got a positive 1 charge, magnesium, positive 2, chlorine, negative 1, oxygen, negative 2. So when those atoms lose electrons, they become positive, like these first two. Those are your metals. And then sometimes atoms need to gain electrons to have that full outer shell. And if they gain electrons, then they become negative, like these guys. They're anions. Okay. Binary ionic compounds then are formed between two monatomic ions. And that's it. So a binary compound is just a binary ionic compound is formed when you've got a positive one of these joining up with a negative, and that's what we're going to look at today. Okay. So some things to keep in mind that, let me just make this point over here since we've got this bullet list going. Binary ionic compounds are always neutral, meaning that collectively as a compound, when these things come together, the charges have to balance out. So the compound is neutral, whereas the individual ions have charges, but when they come together to form a compound, those charges balance out and the compound is neutral. So we're going to see how that works. So let's say that we've got an ion like sodium. Sodium with positive 1 charge. If sodium, let's just look at reaction that we talk about all the time. If sodium were to pair up with a chloride ion, we've got a positive and a negative, and more than that, we've got a positive 1 and a negative 1. So when those two come together, those charges just perfectly cancel, and they form the compound sodium chloride. Okay, and that's how we name it. We stick to the naming rules like we did last week. We say the name of the cation, sodium, it's a D, sodium, and then we say the name of the anion, chloride. Okay? Sodium chloride. And that's a perfect 1-to-1. Positive 1, negative 1, they balance out, and you don't see any charges up here with the compound because it's neutral. Okay, so it's pretty simple when the charges perfectly match up. So let's look at magnesium with a positive 2 charge and oxide with a negative 2 charge. There again, positive 2, negative 2, perfectly balanced. So we're left with MgO, which is magnesium oxide. Okay. Pretty straightforward so far, right? But what happens if the charges don't match up? So let's take a look at this. We've got magnesium, which has a positive 2 charge, and chloride with a negative 1 charge. They don't balance out. Positive 2, negative 1. So you got to ask yourself, what do we need in order to form a neutral compound? Okay. Magnesium has positive 2 charge, and chloride by itself just has a negative 1. So just one of those is not enough to balance out that negative or that positive 2. But what if we had 2 chloride ions? In that case, the positive 2 would be balanced out by this collective negative 2, right? And that's exactly what happens. So when magnesium and chloride pair up, It's MgCl2. And this little 2 is what we call a subscript. Sub means below, so subscript is a little number that's written below, and a subscript tells the number of atoms, or in this case ions, the number of ions. Whereas up here, remember, a superscript is what we call these, tells the charge. Okay, so MgCl2, that just tells us that magnesium chloride has to exist in a 1:2 ratio because it takes 2 -1 chloride ions to balance out the +2 charge of 1 magnesium ion. Okay, so a couple more of those. Let's say we've got aluminum with a +3 charge pairing up with bromide with a -1 charge. All right, there again, different charges, +3, -1. So how many bromines is it going to take to balance out that +3? Yep, it's going to take 3 of these guys, right? So 3 of the -1s to balance out the +3. So AlBr3. And we've got our neutral compound. And the name of that, aluminum bromide. Okay. Aluminum bromide. All right, the only wrinkle to this, what if we have this? So we've got aluminum, +3, oxygen with a -2. You got a +3, -2, so they don't perfectly balance out. And you say, okay, well, if I have 2 of these oxygens, now I've got a total charge of -4 over here. And that -4 doesn't balance out that +3. So we got a little bit of a conundrum there. Well, what if we built out this aluminum one more time? So now we've got 2 aluminums for a total charge of +6 over there. And then if I add another oxygen over here, now I've got a total charge of 6 negative over there, and now they do balance out. So this would be Al2, because I needed 2 aluminums, O3. So it took 2 aluminums and 3 of those oxide ions to balance each other out electrically. So the name of this would be aluminum oxide. Now, I'm going to show you a shortcut that is the best trick in chemistry, and you will use this for the remainder of your days. Okay, so you could do that and figure it out, and how many of one do you need to balance out the other, and how many of that one do you need to balance out the other. But here's the trick. It's called the crisscross rule. I'm going to write it down here. Crisscross rule. And the crisscross rule says when with unlike charges, or I should say unequal charges. So up here we got a 3 positive and a 2 negative, so they're unequal. So with unequal charges, crisscross. And here's what that means. So see how this oxygen has a -2 as a subscript? That's 2 would come down here and then become the subscript over here. Likewise, that 3 that's up there as a superscript, or the charge for aluminum, comes down here and becomes the subscript for that oxygen. That works 100% of the time. Okay, 100% of the time. So a couple other examples of that. Let's say we've got barium, +2 charge. Let's say barium is trying to pair up with Nitride. It's got a -3 charge. Uh-oh, we got +2, -3, unlike charges. So what do? We use the crisscross rule, and that 3 would crisscross down here and become the subscript, so Ba2. This 2 up there would crisscross down here and become the subscript, N2. I'm sorry, this was Ba3. The 3 crisscross down there, Ba3, and then the 2 come down there, N2. And what's the name of that? Barium nitride. And that's it. Okay, so what I'm going to do now is I'm going to pull up the practice for this week and show you what it looks like. You've got the first sheet here that walks you through everything that we just talked about. So you take a look at that if you need to. And this second page here is actually your practice. And here's how I'm going to ask you guys to do this. 1 through 10 up here, you are given the name of the compound, and then you have to come over here and write the formula. Okay, so sodium bromide. Here's what I would recommend and prefer that you guys do. Break each of these down into their individual ions. So take a look at sodium. What is sodium as an ion? It is Na+. Then what is bromide as an ion? It's Br-. Okay, so now once you write down those monatomic ions, it's much easier to look and say, okay, well, how are these things going to crisscross, or how are they going to balance out? So in this case, sodium with a +1, bromide with a -1, they simply cancel each other out. It's a 1-to-1, and the formula is NaBr. Okay, so do that with each of those. Write the individual ions and their charges, and then crisscross if you need to get to the final formula. Now, 11 through 20 at the bottom, this is the easy part. You will buzz right through it because you're given the formula, and you just have to write the name. And all you do is you just name these ions here. So K2, that is potassium. And how do we name those cations? We just say the name, potassium. O, that's an anion. And how do we name those? We add the IDE, potassium oxide. So you just do that with all those. You just name them. You say the name of the first one. And then all of your anions, the second element, those get the IDE at the end. Okay. All right, that's it, guys. So if you have any questions whatsoever, please reach out to me, message me. We'll chat on Teams. And otherwise, you guys have a safe week, and let me know if you need help. All right, see you guys.